Yeah, that's amazing. One other comment that Julie made was it's this idea that we're teaching specific skills clearly, directly, and then practicing them until students demonstrate mastery. And Jenny, I'm going to pop to you first before Sarah. You had mentioned the same idea of building students to mastery. How do you determine what mastery is?
That's a great question. Not really. Well, so I've actually I'm thinking about phases of learning or the instructional hierarchy. I have tried to stop using the term mastery and started thinking about, has the student met an acquisition goal? Is the student ready? Is the student working on fluency with the skill, or is the student in maintenance? And maybe mastery is what we mean by the student is ready for me to kind of loop this into maintenance review type thing, or is this ready for me to target for generalization, right? So I've started breaking my goals, and when I teach pre-service teachers or do PD, I break it down into what do we need for acquisition, and then how am I going to change my instructional strategies to build fluency, especially since I work with students with more extensive support needs. But I would say mastery is what do we need to think that they're going to be able to maintain this. So what level does that behavior need to be at, that we can consider it independent, that it's at the appropriate rate, that it's that they can do it with more ease, right? So then the answer would be, it depends.
Sarah, did you have anything to add there, or do you want me to fire the next one to you?
I completely agree. I think that this is it's an iterative process, right? To think that a student has mastered one skill and now magically we just move on to something else without, building on it or moving to that next phase of learning. We know that's how kids learn. So that's a really great way of thinking about it.
Yeah, so there's another question, which Sarah, I'll send it to you first, but I'm sure Jenny will have something to add to this. But it's this idea of like scaffolding, right? So it's like teacher, right? If the teacher's doing it, we can't just throw students to independence, right? And so Amy's like, yeah, we need to strategically scaffold away before moving to total independence. And so what types of supports can you use, and then slowly perhaps weed away layers of your support across time? And I was kind of thinking about the prompt hierarchy, which is something I know you and Jenny incorporate a lot in your work.
Definitely. So we have used a lot of prompting hierarchy in our work, and that can help us when we're delivering prompts to the student. It can be a more intrusive prompt so that you're ensuring that the student is able to get that correct answer and they're not sitting there for long periods of time without knowing the answer. And that helps, again, build their accuracy, but it also helps build their confidence that, yes, I can do this. Other things that we've provided that are fadeable, you can fade them, right, are types of visual supports. We've used self-monitoring very successfully with students so that they can check their own work. They take pride in their ability to get certain steps correct. We have broken things down into task analyses where they can walk along. And again, we've then chunked steps. So you can take that longer task analysis and you can chunk the steps together so that the student is then completing fewer steps, but still completing the same problem successfully. And I think back, even if from like a broader perspective, something like the CRA framework, where you are using concrete manipulatives and then you're moving into representational manipulatives, and then the abstract, that's another way to think about scaffolding supports, specifically in mathematics, where you can give different types of supports to students directly, and you can fade them over time as the student becomes more proficient.
Did you have anything to add, Jenny? Because I know you love the prompt hierarchy.
I don't. I do. I think that's why we like to use the system of least prompts, because it helps to prevent prompt dependency. Most least prompts really isn't applicable to academic skills. And so I do think it's helpful to think about what is the least intrusive prompt to start with. And so for folks, especially like behavior analysts or people who are really familiar with systematic instruction in other areas, and are now applying it to academics, they might have this very rigid, verbal physical model, or, very rigid. And I encourage people to be flexible of thinking about what is just a little hint you might be able to give, and then what's maybe a little bit more. And if you feel like you really need 3 levels, what's a little bit more. But one of, in our prompting hierarchies in Sarah and I's work, typically the first level is referring them back to the supports they have, right? So our goal is, how can we teach, especially as you get into secondary grades, how can we teach them to self-manage the supports they have? And remember, like, step 2 on the checklist says, or, go back and check, what you're doing, so that they're then referring to that. And technology can really help, because then when we have students who maybe aren't readers, and aren't able to maybe decode what that has, we can pair pictures with that considerate text. I've even, my dissertation study used an app where I was able to program, so if they touched it, it read it aloud, the step, but then they could touch a little question mark next to the task analysis step, and it delivered the specific verbal prompt as well. So they really only needed me for the model prompt. That would have been really cool if the app had not crashed all the time and the students never wanted to use it. But in theory, like, it was beautiful. So you want the students to also self-manage their prompts, because I have found over and over, students will fade things way faster than an adult will.
Oh, that's an amazing observation. Mm-hmm. I was talking to Brian Ponce the other day, and like, even simple things like, let's say you're working on sums to 20, right? And you're really focusing on, okay, we're helping students maybe identify the idea of the join addition model versus a part whole structure. And it's like, you can use manipulatives all day, right? And students they might get really accurate, right? Yet that is like, as soon as you want students to use that concept of sums to 20 in a new context, it's like, we can't keep using the manipulatives. It is slowing us down. And if you think about like cognitive load theory, I can't be devoting so much of my cognitive energy on this lower level task if I need to allocate it to a higher one. And so, like Brian said, he saw a bunch of kids, they would begin to use fingers, right? And you're like, okay, fingers might be a slightly more efficient manipulative than a concrete one, but he said he's literally watched students' data where they'll cap out at, I don't know, I think he was saying like 25 digits correct per minute. And they could never get past that line if they continually relied on their fingers. And eventually you would get them to fade away and be like, oh, I can automatically recall 5 + 4 is 9. I don't need my fingers to count. And then it's just freeing. Anyway, I could talk forever about this, and I feel like I'm rambling. But I think that's really important, of like, as we fade away supports, students are internalizing whatever mathematics we're teaching, it's freeing them up.
But you have to make them want to do that. And you have to make them want to fade it. It's really hard to make people want to do things they don't maybe want to do, turns out. And that's where the self-monitoring, the goal setting, the self-graphing, like that really helps with that component.
Yeah. Samuel had another really great question, which I don't know which of you wants to take this. Well, it was more of a comment, I guess. But he was saying, thinking through really carefully the types of examples that you're using for modeling guided practice and independent practice. And so I don't know if you all have comments on, and actually even specifically, if you like a priori kind of know misconceptions, how to think about using those in regard to non-examples from the get-go. And so I don't know if either of you have thoughts here.
I think that's a really great point. And Corey, you brought up one of the things I was going to say, which is, it's not just examples, right? We have to give students examples and non-examples, and our non-examples should be things that we already know are likely mistakes that the students are going to make. So if we are talking about quadrilaterals and we're teaching them quadrilaterals have 4 sides, here are examples of quadrilaterals, we need to give them very obvious incorrect non-examples, so like a circle, but you also need to give them close examples, something that has 5 sides, and make sure that they understand that that's a non-example and why it's a non-example. And then moving into the next opportunity. So if you model those and then you're moving into guided practice, you want to make sure that you have modeled problems that are at least as difficult as the problems you're going to now ask them to complete independent or with other people and independently, rather than I model something that is relatively easy in comparison, and now I'm going to give you more difficult problems to do on your own. You want to make sure that you're taking that burden on, if you will, so that they are proficient when they're doing it independently.
Mm-hmm. I think something that I've realized I haven't done in some of our research that I should, so I now incorporate in PD, is also using example and non-example of when a strategy is appropriate. right? So, and here's an example. We, Sarah and I, and some of our research taught students to solve percent of change problems, right? Within the context of coupons. So if you have a coupon for 20% off, then you can use the strategy. But I realized, like, we never told them, when would you not use the percent off strategy? So what if you had a coupon that was just $5 off or $10 off versus 10 or 15%, right? And so now if I was going to do that again, probably the first, or at one point in that, there would need to be a decision of, it doesn't mean that we have to teach both things. It doesn't mean you have to teach, oh, here's, you know, the what to do when it's just $5 off, and here's what to do when it's 15% off, necessarily at the same time, especially when we're talking about students with autism and intellectual disability, that you're going to need to really narrow your learning targets in each session. But you should at least tell them, like, teach them to decide, is this the right strategy right now or not, right? So it's almost that multiple exemplar training or discrimination training of, this is that concept, this is not that concept. And we do this in some of our other things, like, you know, discriminating schemas and problem types and things like that. But I had not thought down to it to the level of what stimuli I'm giving students. And would this be an appropriate time or an appropriate way to generalize the skills?
And
Yeah,
when we,
oh, go ahead, Sarah. Sorry,
I was just going to say, and when we do it, we see that the students are more successful in generalization. So they don't overgeneralize because we have already given them the tools that they need to be able to discriminate.
Yeah, one other thing, I'm going to show this and I'll post it later. This book is really good for those of you who are interested, and I'll post it with the video. But there was in it, it basically highlights why you can never use one example to totally explain a concept, right? And so if you think about fractions, right, I can't just say, here's a fraction and show 1/4 and walk away, right? Because students could inadvertently think, oh, the numerator always has to be smaller than the denominator. That's not true, right? 11/4 is a fraction. Or they might inaccurately think that, oh, there needs to be a 4 in the denominator for it to be a fraction, right? So you literally will have to go through a series of examples to show the boundaries of what is a fraction. And I just think that's like it's uber important. And I'm realizing it's something the pre-service teachers I work, we have to spend a lot of time thinking through that, of what work examples or examples am I going to select. I had another question for you all. How do you figure out, so part of explicit instruction, and Jenny, you mentioned this earlier, it's not only the delivery portion, it's the planning portion, right? We have this whole instructional design. And so let's say we're doing something with fractions, right? Maybe I'm adding fractions, right? Well, theoretically, I can stick with fractions that only have thirds, fourths, and fifths as the denominator. I can use improper fractions. I can use mixed numbers, right? Like, if I'm planning a lesson, what do I do, right? Do I do all of those in one lesson? Like, how do you make some of those decisions based on your students to figure out how wide of a scope for the concept you're going to do in an individual session versus how narrow are you going to go, with the risk of being too narrow, them perhaps overgeneralizing certain things?
I think there's pros. Oh, go ahead, Sarah.
No, you go.
Pros and cons to both, but you go ahead while I formulate my thoughts.
I was going to say the same thing. I think it depends very much on the group of students you're working with. So knowing your students, knowing where they're at, if they have already been exposed to fractions before, so using your example, if they've already been exposed and they have an idea of what these three things are, then it makes sense to introduce them all together to make sure that they're understanding the differences between them. On the other hand, I've worked with groups of learners that wouldn't be appropriate. The best idea would be to introduce one thing at a time, and then at the end, come loop back around and do a discrimination training where we talk about the difference between the three. So I think it's really about knowing your group of learners.
Yeah, and I think there's trade-offs of, rate of learning. So you might see, if you introduce a lot of things at one time, you might see a slower rate of learning for some students, but they may eventually get it. But you have to be really explicit about that discrimination, like within each session, versus if you kind of parse things out, they may acquire each of those really quickly, but you're going to need to embed that discrimination training sort of in between. So I think you probably get to the same destination in probably about the same amount of time. And I'm just thinking about some studies that I've done where I've done things both ways. And some of it comes to your preference and your learners and what it is that you're teaching. Which
that's
one
a really
might be
good
more
point.
efficient.
Yeah. And I think the one thing that stood out to me is if perhaps you focused on more discrete skills, the likelihood of mastery or acquisition is going to be high each session. It's then that discrimination training of, oh, wait a second, now we have improper fractions we're adding. Now we have proper fractions we're adding. What are the differences here? You might have to do some of that work on the back end once the initial skills are mastered.
Or if your instructive feedback or your non-targeted information skills. So you also have to think about your skills as an instructor, right? So how good are you at giving instructive feedback and non-targeted information? So are you going to be good at like embedding that all along the way or not?
Yeah. One other thing, this just kind of struck me. A lot of the people who responded used the term systematic when describing explicit instruction. And I don't know if that either of you have any thoughts on why we oftentimes think of the word systematic in regard to explicit instruction.
Well, the IES practice guide, the new IES practice guide that came out in March for, I think there's 6 practices for learners who struggle with math or however they phrased it. The first one is systematic instruction, but what they really mean is explicit instruction. If you read it, because sometimes for people from an ABA perspective or low incidence disabilities, we think of systematic instruction a little bit different. We think of things like constant time delay and prompting hierarchies and that, not necessarily just explicit instruction. But I do think it's systematic because it is very intentionally planned. Right. And so I think of it as you have this decision tree in your head at all times. I'm not saying other teachers don't, but maybe the instructional decisions are a little bit more formulaic, if then.
Yeah. Oh, sorry. Go ahead, Sarah.
No, go ahead.
Talk at the same time.
It's completely fine. I was going to just reiterate that I think the planning that goes into explicit instruction is extremely systematic. All of these instructional decisions that we've been talking about here, deciding what gets taught together at what point in time, those things are all made in a very systematic way. And so I think that when I hear the term systematic instruction embedded into explicit instruction, that's how I think those things are related.
Yeah, I want to put a quick shout out to Jessica Tost at University of Texas. She's doing all of this work of like, we are scientists, right? And like helping teachers really see themselves as you are truly a scientist, measuring the environmental contingencies and see how students respond, right? And I find that so beautiful for us to move in that lens of saying, no, all these kids in my class are going to learn. I am going to figure out what things I need to change to ensure that occurs, right? But that's just my pitch because I love
this internal locus of control. So I love Bill Heward anyway, as a person and a scholar. But you focus on the alterable variables, right? So there's so many things we cannot control, and I personally feel like the list is growing. But we focus on the things we can, right? So what in our classroom are the instructional variables that we can alter to affect student behavior change, and everything is behavior. Right? All behavior is learned and therefore can be shaped. And that includes learning math.
Yeah. If there's any other questions, put them on the chat right now before we wrap up. One other thing I was going to ask, maybe you, Sarah, given your background. And I think I'm going to try to have Stephanie Morano do another webinar a little bit later on this, but something she's been working with her pre-service and in-service teachers on is how do you take a curriculum, right, that is not structured at all like explicit instruction and attempt to piecemeal something together from that adheres a little bit closer to explicit instruction. And Sarah, I don't know if you had experience with that as a general education teacher.
So interesting, because when I was in my undergrad career, we had to take Basel textbooks and we had to take them from what they were and make them more constructivist, which I found very ironic, because once I got into the classroom and started to implement more constructivist type learning experiences, I found half of my kids were not learning, or more than half of my kids. And so then I had to go the other direction and make them more explicit. So I think that, and I think this is where we come back to that model, lead, test framework, right? And thinking about, okay, how can I break this down into those opportunities and make sure that those things are all there? I really like the videos of explicit instruction that are on the Archer and Hughes website from their textbook. I think they give such great examples of how to use choral responding to get the students engaged and how to have them actively participate. And I know for me, it reshaped when I thought of model, when I watched what a model looked like from their perspective, I thought, oh, that's not what I thought a model was. And it completely changed my teaching behavior. So I think that it's practice, right? It's doing it, it's monitoring your students' behavior and seeing, are they being successful with what I'm doing, and using the resources at your disposal to try and make sure that you're doing what you can do to help them be successful in that environment.
Yeah, that's perfect. I was watching one of our pre-service teachers implement a lesson from everyday math this past week in an elementary setting. And it was interesting because it was like 3 more complex situations, right? And it was funny to me because the only thing they were really focused on is what the heck do you do with the remainder, right? In some situations, the remainder would require you to round your quotient up, given the context. In other situations, you can throw the remainder in the trash, it doesn't matter. And in other situations, you might want to represent the remainder as a fraction. That was the whole goal of this, right? And yet students were having to do like a lot of work. There's only 3 problems, but a lot of work just to get to the situation of what do I do with this remainder? And I was like, okay, in the middle of this, just quickly throw out like 5 or 6 different examples with remainders and ask them what to do, right? Like rapidly. And I think it was just something, she was like, oh, I didn't really think about that. I didn't want to deviate from this. And I'm like, no, you're just focused on learning here, right? We're focusing on getting students to understand what we do with the remainder. That's the goal of this, right? And I just think like, I don't know. Yeah. Anyway, I feel like we're all great here. We don't have any other questions. So just so everyone knows that's on this chat, I'm going to clean up our recording and then post it on our YouTube page. And then I'm also going to post the interview on the YouTube page. So you can go there and share it with colleagues if they weren't able to attend today. And be on the lookout. We will be doing another one on the math rope, hopefully within the next couple of weeks. And then we'll do another one. I think we have that one planned for the beginning of December. And it's going to be focused on executive functioning in math, math anxiety, and timed assessment. So all of the hottest topics in math right now is what we're going to be talking about then. So thank you all for joining us. This has been great.
Thank you, Corey.